All right, hello class. I'm getting a little tired, but I kind of want to keep going. So here's video 4. Is this the 4th? Still got the dog in the background, so that's good. See him squirming around a little bit. Anyway, so this homework is a double whammy. I think on your paper it only says volume of cones, but I mean, look at the shape. There's a pyramid, so obviously this is going to be about pyramids too. Number 1, 2, 3, 4 are all pyramids, but 5, 6, 7 are cones. So let's get down to business. The good news is they're very, very similar to what we've been doing. The big difference, of course, is that to find the volume of a pyramid, it's not just base times height, it's a third of the base times the height. It's a third of the base because, well, obviously, pyramids are smaller than prisms. If base times height gives you the volume of a whole entire prism, well, a prism would have another rectangle up here on top, would connect the dots. That's terrible. Mr. F, you can do better than that. Sure, let me do better than that. Remember, a prism would have two bases that are congruent and parallel. So if I kind of trace the base of my pyramid, and then if I imagine dragging that up to maybe here, so that the tip of the pyramid is at the center of that base, and then if I connect that down, there's no comparing a prism to a pyramid. The prism's obviously way bigger. And the pyramid is much smaller. You know, in class we talked about this. Many of us probably thought that the pyramid was half as big, but it turns out it's even less than half. It's only a third as big. It's much, much smaller. And we watched a video on this. I'm not going to pull up the video again. But we talked about this with cones and cylinders. So there was a video that actually showed a cone that had the same base and the same height. They took that cone and they kind of placed it inside of the cylinder. And then they kind of imagined like melting the thing down. And when it melted down, did it fill the cylinder halfway? Nope. We saw that it filled it only about a third of the way. And then when they added a second one, then now you're 2/3 up. Finally when they added the third one, that filled it all the way. And that was sort of a visual proof that for sure the volume that we wanted would be 1/3 of the old volume of a prism or a cylinder. All right, enough talk. I'm sure I could have just told you guys that it's 1/3 and you'd have believed me, but I just want to remind you why. So it's going to be 1/3 base height. Now we're back to bases that are not just circles all the time. Our bases can vary. This base happens to be a rectangle. So that means to find the area of our base, we need to do base times height. And then we need to multiply by the height to find our volume. So we need to plug in. Our base is 14 by 30. So enter those values. And our height we can see is the 24. Alright, so now that we've got a third, we're back to having these choices. Do you guys want to just multiply all this crap together and then divide by 3? Or do you want to do what I do? Which is I usually look for somebody who's cleanly divisible by 3. I could divide the 30 by 3 or the 24. Let's do the 30. If I chop 30 by a third, then I'm now going to have a 14 times a 10 times a 24. And then I just do this math. That means I get a 140 times a 24. And at this point, I don't know what that is. So now I'm reaching for my calculator. So 140 times 24. Apparently is 3,360. So that must be our answer. And if we're in feet, then these are cubic feet. And that's it for number 1. Number 2. Basically the same. Our formula is still 1/3 times the area of the base times the height. Now since our base is a square, 10 by 10 square, how do I know it's a square? don't forget these little tick marks. Those tick marks mean things are congruent. So they're telling us this side's 10, that side's 10, that's 10, that's 10. Our base is a square. So to find the area of a square, we're still going base times height. So substituting in, we've got the 1/3 times the 10 times 10 times the height of the pyramid, which would be this 12. Okay, so what can I do? Well, I can do 1/3 of the 12. That's going to give me 4. Then the 10 times 10 is 100, and 4 times 100 is 400. So the total volume here must be 400 cubic yards. That's it. Number 3. So, alright, a little different. We're going to go 1/3 times base times height. I don't know why I put that parenthesis. Get rid of that. Now we plug in. This time our base is this triangle. And the area of a triangle is 1/2 times base times height. And of course, you still have to multiply by the height of the pyramid. So let's substitute in something I like to do. You don't have to, but I am going to go ahead and just combine 1/3 with 1/2. We're multiplying them, so we would get 1/6. Then the base of our triangle is going to be this 4. The height of our triangle is going to be the 6. And the height of the whole pyramid is that vertical dimension here. That's 5. So in goes 5. Alright, so this one kind of played out nicely. I know I can just take 1/6 of 6, and then I'll have 4 times 1 times 5, which of course is 20. Cubic meters. So what's happening with number 4? Pretty similar. Yeah, so we just saw a right triangled pyramid, right? A right triangular pyramid. So here's another one. So I'll set it up the same way. Almost screwed this up. Almost forgot the 1/3 in the front. 1/2 times base times height is the area of our base. Now we go to substitute, and notice this is another one of these problems where you're given the volume. You're asked to find the height. So the volume is going to be 80. The 1/3 times the 1/2, I'm still going to let that be a 1/6. The base is 6. The height of the triangle is 8. And the height of the whole daggone pyramid is x. And x is what we're solving for. So to do this problem, we've got the 80. I can do 1/6 of 6 again, and that's just 1, and 1 times 8 is 8, times x is 8x. So to finally find the answer, you just have to divide by 8. And you end up getting 10. 10 what? 10 centimeters. And that's number 4. So we'll go on to the next one. Oh, great. So we're done with pyramids then. That's all your pyramid practice. If you need more practice with pyramids, I did make another delta math. You could go into delta math and do it. You could do all the pyramid problems you want to. But for now, we're moving on to cones. So for cones, remember, our formula will still be 1/3 times base times height. And since the base of every cone we're going to deal with is a circle, that means our formula is basically going to be 1/3 times pi r squared times height. So that's our formula. Now we do what we always do and we substitute in. And we saw this before. Some of y'all, oh, that says 8. Okay, I thought that said 3 for a second. Since it's 8, we can obviously chop it in half, and our radius is 4. And the 4 is what we care about. We don't care about the 8. So for our radius, substitute in that 4. And for the height, Well, the height is going to be that distance from the top down to the bottom. So that's going to be 7. Plug that in. Notice this time we can't take a third of anything. So we got a third times pi times a 16 times a 7. Well, if you can't take a third of anything, then just leave that 3 in the denominator. Go ahead and multiply the numerators. The numerators being a 16 times a 7. So I can do that in my head, but I'm not gonna. 16 times 7, 112. Told ya. So here we go. Our numerator will be 112. Pi, don't forget the pi. Our denominator will be 3. Again, we can try to divide by 3, but I'm telling you it's not going to work. If I take the 112 and I try to divide by 3, then I do get a decimal. And I said I don't want decimals. So I'd much rather that you just leave your answer as the fraction 112 pi over 3. Okay, don't try to clean it up for me. This is the form that I want. And those must be cubic yards. So don't forget your units. Gotta give me those units. Alright, after 5 comes 6. It's another cone. So you write the formula, which is volume equals 1/3 times pi times r squared times height. And everything seems great. You got this 1/3, you got this pi, then you got your radius. Oh no, we don't have our radius. Our radius should be this dimension. So we don't have it. What do? Well, we can see that the height of a cone and the slant height of a cone and the radius of the cone, they all form a right triangle. And when you have right triangles, you can use Pythagorean theorem. So a squared plus b squared equals c squared. We're always making sure that the hypotenuse is what gets plugged in for c. So that'll be our 15 squared. Now a and b can be the r and the 12. I don't care who's who, it doesn't matter. Let's let a be r, so we square r. B will be 12. So we do 12 squared. And you can reach for your calculator if you want to. 12 squared is 12 times 12, it's 144. 15 squared is 15 times 15, that's 225. Now to solve for r squared, we need to isolate it, so you better subtract 144 from both sides. Those will cancel. We still got r squared, and it equals what? 81. So 81 is not the answer though, because we still have r squared. So you need to take the square root. And square root of r squared is r. Square root of 81 is 9. So we now know that our radius here is 9, which means we can now take that 9, plug it into our volume formula. And then we need our height, and our height's easy to come by. The height is 12. We were given that, so we can plug in a 12. That 9 is supposed to be getting squared, right? Sure is. Alright, so again, before you do anything, before you multiply by a third or divide by 3 or multiply, you got to do your exponents first. So this thing will be a third times pi times 81 times 12. Now again, you could multiply everything together and then divide by a third, but I'm actually going to just go ahead and divide the 12 by 3 right now. That'll leave me with 4. So all I need to do to get my final answer is multiply the 81 by 4. That'll be 324 times pi, so 324 pi. But that's it. Those are cubic centimeters. And I'm not going to ask you to round your answers off to the nearest tenth or whatever, but if you really wanted to do 324 times pi, go ahead, but I'm just leaving my answer as 324 pi. Okay, that's 6. Are there any more? Yeah, this is the big composite problem. Alright, fine. So to do this, we would break this down just like we broke down some of the older problems. We said we want to do this as the cylinder, and we want to do it as the cone, and our total volume would be what these two volumes add up to. So let's just write one nice equation. Our cylinder, remember, is pi r squared h, and our cone is also pi r squared h. But since it's a cone, not a cylinder, it'll be 1/3 pi r squared h. But there's our formula. We just have to plug in now. Oops. So pi r squared h plus 1/3 pi r squared h. And I'm getting slightly hidden by the calculator, so we'll just hide it for the moment. Okay, let's plug in. So what's the radius of the cylinder? That would be the 5. So plug in 5. What is the height of the cylinder? That would be the 17. So plug in 17. Alright, now we're down to the cone. What's the radius of the cone? Well, that's also 5. Of course they have the same radius. They fit together, so they must have the same radius. Plug in 5. Now we need the height of the cone, and the height of the cone is right here. It's labeled as 6. You guys probably can assume that we're not necessarily going to give you that dimension. And we probably shouldn't give you the 8 either. I think the 8's probably not even possible to be true. So pretend that wasn't there either. Pretend for a second this was the question and you did not have this height. I hope that you'd know you could still find it, because look, they gave us 23. They said the whole thing's 23. So if this piece here is 17, then we can find the other height for ourselves by just subtracting. We do 23 minus 17. That leaves us with 6. So there you go. And I know we already knew it was 6, right? I know it was already there. But I'm telling you how you could potentially do it if we had given you less information. So whatever, it's 6. Plug in 6. And then start calculating. 5 squared is obviously 25. 25 times 17 though, I'm not so sure what that is. So, sounds like I better bring back my calculator. And it sounds like I better do 25 times 17. So 425. And the pi, 425 pi. Now what about this? That's going to be 25 times 6, but with a third. So I could actually just do a third of 6 right now. That's a 2. 5 squared is 25. 25 doubled I can do in my head for sure. That's going to be 50 pi. Now, because both of these, oh, you can't see the 50 pi. There you go. All right, anyway, now, since both of these are in terms of pi, we can add them, and we add them by just adding the coefficients. So that'll be 475 pi. And these are all centimeters, so these are cubic centimeters. And that's it. That's the area of that composite figure. I think you'll see one of those on your quiz, so just be ready. I think this pretty obviously breaks down to a cylinder and a cone, so you just find those two volumes and add them up. Okay? I do believe that's the end. Yep, we just have the one more to do on spheres. So I'll let you go. See ya.